Hello friends. Now we have came to chapter 4 where we go to the Jupyter notebook and go through all the code demo. So let's start it. So I have launched my Anaconda prompt and now I'm in the directory. Now I'm going to activate my environment. If you remember, we learned about how to create our environment where we install NumPy, Pandas and all the dependent libraries in I think chapter 2. So you can refer to that video if you haven't done so. So I've created this environment and I'm going to activate it. It's called as Alexander. So as soon as I activate it, you can see that now it's changed from base, which is a default environment. Now we are moved to Alexander, the virtual environment, where we have installed all our NumPy modules. Now from here, as we mentioned that we are going to launch Jupyter Notebook. So I'm just going to run this command and it will open our notebook in our default browser. Now, as seen here, after we launch this, now we have got our default browser open here. So here I have already created our notebook here, which is shown here as .ipynb, which is the extension for our any Jupyter notebook by default. As soon as I click it, it will open my NumPy module. Now let's start with our very basic array fundamentals. We will see how to create an array, a NumPy array. The very first thing is that I need to import NumPy as NP. NP is by default used as a convention. We can put whatever name we want, but NP is the default convention. So as soon as I type this command import and NumPy is NP, I can click on Shift Enter, which will move me to the next line. Now NumPy has been imported. Now first of all, let's see that how we can create a NumPy array. For the first option that we have, first of all, we create a Python list. And after creating that Python list, we'll create a NumPy array out of it. Now let's create our first list called as myList, in which we have given 1, 2, 3, 4, 5 numbers in square basis. This is how we create a list in Python. And now if I just print out this myList, we'll Shift Enter here. We can see that our myList is consisting of all this like 1 to 5 integers. Now we can also use this type command to confirm that this is a Python list. So for that, I use this type function. Inside that, we have passed our variable, which is myList. And as soon as I press this Shift Enter, it will show me that this is the list. Okay. Now, our first step is that now we have got this myList as a list, Python list. Now we have to create an ND array using this list. For that, we can use this command as given here, np.array. This is a very handy way that we can just call this NumPy module, np, which we imported initially, and use .array method and pass this myList as an argument to it. It will return me a myArray, which is a NumPy array created out of this myList, which is Python list. And now we print out this content here. So if I press Shift Enter here, you can see that this array is created here. In the previous version, when we created a list, it was just showing me this list of numbers from 1 to 5, and the type was list. But here, when I use this myArray, when we create using np.array method, once we create a NumPy array out of this list, it is giving me as an array, which is different than a list. That's why it's a NumPy array. We can confirm this again by running this type command, type function here. So as I pass this type command, we can see that this numpy.ndarray, ND stands for n-dimensional. So now it's numpy.ndarray object that we just created. Now this is how we create. This was a very simple way using this numpy.array method, np.array method, to create a NumPy array out of a list, a Python list. Now let's see that how we can access the array elements. Accessing an array element is very straightforward. It's same as how we access any component of a list or a tuple in Python. We just need to pass it as an array indices here. For example, my array, as we have seen, that it starts from 1, 2, 3, 4, 5. So 1 is actually the 0th index, 0, 1, 2, 3, and 4 like this. The same way as we access like any normal Java array or a C++ array. And similarly, that how we actually access a list or a tuple element is very much similar to that. So it's very straightforward. For example, if I just use this myArray1, so it should return me 2 because 0, 1, this is the element which we are talking about when we talk about the index 1. Shift Enter, it will give me 2 as expected. Now let's talk about mutability, right? Now ND array is mutable, similar to list. For example, only for tuple, we have seen that once the tuple is created, we cannot change its content. But for list and ndarray, it's same. As soon as we create an array, we can change the elements of it. We can add new elements to it, like that. So now let's give a demonstration here. For example, for my array, the second index is actually 3, right? So if I talk about this, so we have got 0, 1, 2. So at array index 2, which is the element is 3. So if we want to change it, because as we mentioned that ndarray is mutable, in that way we can change it and assign it to any other number. So here I am putting this from 3 to 100. So as soon as we do it, we'll change it, and we can see that the array elements are changed from say 1, 2, and the third, the number 3 is replaced with 100. And so we can confirm that ndarray is mutable, same as list. And so some other comparisons which are similar to list, Python list, is the slice notation. If we want, like the original list, Python slice notation can be used for indexing. For example, if you are aware of all those like indexing or sequence or slice notation in for Python list, the same way it works for myArray, for numpy array. So here, when you talk about this colon 3, what we mean is that all the elements starting up to the third element. So this 3 is exclusive. So what it means is that all the elements, give me all the elements of this numpy array called as my_array, starting from 0 until 3 and excluding 3. So it means that everything which is from 0, 1, and 2, because 3 is exclusive. So this is what we see when we run this. When we run this cell, is that once we provide this colon 3, it will give me the 0th, first, and the second values of this numpy array. So let me run this, shift enter again. I can see that it is giving me 1, 2, and 100 as we expect. 0, 1, and 2. It didn't give me 4 and 5. It's very much similar to Python list indexing. But here, however, the similarity ends here, because for a Python list, when we actually do this type of index like slice notation, it creates a copies of the element. For here, so for example, if I use the list here, the list that we created before, and you use this notation, it will create a copy as an output. The original list would be intact. But for the numpy array, the same slicing annotation, it will create a view which refers to the data in the original array, which means that if we are making any changes in the view, it will also reflect those changes in the original array. This can be seen here. For example, if I create my array starting from 3 to the end of the list, so it should be giving me 4 and 5, right? So here, when we start, when we use the slice notation and we start from anything, it's inclusive. But for the second point, it's exclusive. This is a small difference that we should be aware of. So when we provide this 3 column, which means that it should be giving me third and the fourth element, which is the last element. So that's why it will give me 4 and 5. So let me quickly run this. So as you can see that now we get array 4. Now we have got, this is actually the view of it. It's not actually a copy. It's actually a view of the original array. And if we make any changes in this array 2, which is actually the view of the original array, the changes will be reflected back to the original my array. So let's see that. Now we have got this array 2, which is a view of the original object. Now if I mutate this, the 0th element from 4 to 200, so let's do it now. As you can see that now the array, the view of the array 2 has been changed from 4 to 5 to 205. Now we can see that the original array also gets modified. So if I just print this, we can see that now original array is also modified. This is a big difference, and this is sometimes asked in the interview as well, that how does the slicing index is different than Python list than the numpy arrays. This is the answer. Just revise this, that whenever we are slicing any Python list, it will create a copy of the original list, and whatever the changes that we are making the copy, that will not actually change the underlying or the original list. But for the numpy array, when we use the slicing index, it will create return a view which is backed by the original array, and whenever we make any changes in the view, the same would be reflected in the original array. This is the important difference between Python list slash indexing and a numpy array slash indexing. Now here we are talking about, so far we are talking about the 1D array or a vector. So now let's talk about 2D list. 2D list is very much similar to like a two-dimensional array in Java or C++. We just need to add extra square braces, and for each of the indices here, for each of the like rows and columns, we can see that there are like 3 rows here and 4 columns, which is create a sort of 2D matrix, just like an Excel, in which we have got 3 rows and 4 columns. So if I just print it out, so you can see that it is able to create this 2D NumPy array. Now here, there is a small subtle difference. Now we have created just a list, not an array, because this is a 2D list. Now if you want to create the 2D ND array, again we have to use the same command as we used before. We have to just call np.array, pass this list, and then in return we'll get the NumPy array of this 2D list. So let's run this, and now you can see that here it is actually showing me in the matrix formation. When we print out the list here, it is just showing me in the linear, but this is a small display thing that is present in the ND array, that it will display the matrices in this format, where we can easily see the number of rows are 3 and the number of columns are 4. So this is how it's very much similar, that how we create a 1D array from a list and a 2D array from a 2D list. Just remember this command, np.array. Now accessing an element, a 2D array, is very much similar to how we access a list. For example, if I for this, just need to remember that although we can use comma, but this is not a better notation. The best way is to actually access elements is by using 2 square brackets. For example, for the first one, it will actually give me the row that we're looking for, and the third is for the column that we're looking for. For example, here, when we print out this, what we mean is that we want to access the second row, because it starts with 0, 0th index, as we know. So it's the second row and the 4th column. So if I just press this, it will give me 8. You just compare this. So we are talking about the second row, 0, 1, and the third column and the 4th column, which is 8. That's what 8 is printed here. Now there's one more small difference, that how we access a 2D list and a 2D array. For example, here we have seen that when we are accessing a 2D list, we are specifying 2 square brackets, in which the first is the row and the second is the column. But if I want to use only the single bracket with the comma notation here, this will not work with list. Suppose if I comment this out, uncomment this and then type shift enter, you can see that it's blocked here and it's giving a type error, because this is not how we access a 2D list by using this notation. So let me again comment it out. So this is the only way we can access an element, by providing 2 square brackets. But for array, it's possible. So let's see. For array, we can specify by just using 1 square bracket and then providing with a comma. Here it should be able to give me the element. I do shift enter, there's no type error, and we can see the element is there. So this is another difference, that how we access a list, or a 2D list or a 2D array, by using this notation. So just to revise that what we learned in our previous video is that when we talk about 0D array or a 0-dimensional array, this can be referred to as a scalar, which is a mathematical concept. What it means is that it's only one value. When we talk about only 8 numbers, this is a scalar or a 0D array, 0D value. When we talk about 1-dimensional array, it is in mathematics, it's also called as vector, which means that only 1-dimensional array, which is having only similar to a list that we have. For a 2D dimensional array, for mathematical concept, is called as matrix. The one we just talked about, in which we are talking about rows and columns, right? This is like a sort of matrix when we represent it in the terms of mathematics. But I think we should avoid it. And similarly, for say an ND array, it's any type of which is greater than 2, which is referred to as tensor. And we have talked about it before, that all those TensorFlow and PyTorch, those are based on this concept of mathematics. And any type of ND array is called as tensor. But I would suggest that it's better to avoid these mathematical terms, because ND array operations are slightly different than the mathematical objects that we're talking about. For example, when you talk about matrix multiplication, right, in which we are trying to say a 2D type of thing that we want to multiply, this matrix multiplication is totally different from the array multiplication. When we will learn about the ND array multiplication later on, but this is totally different. That's why I mentioned that don't use these mathematical terms when we are learning NumPy arrays, because these operations are different. Okay, so this was all about the very basic array fundamentals. Here, just to summarize, that what we learned is that how to create a NumPy array using a list on a 2D list. So we just first of all imported NumPy as NP. Then we learned how to create a list, and then how from a list how do we create an ND array by calling this np.array. Then we learned about how to whether it's like what about the mutability, what are the common things about a list and a Python. We learned that ND arrays are also mutable, same as list. And whenever we try to modify any array elements, it would be reflected in the underlying array. Now, for the slashing and indexing, we learned that when we are using slashing index operations for NumPy array, these are actually created as a view, not as a copy as in a Python list. So whenever we make any changes in the view, then the original array would be also mutated. Similarly, we learned about the 2D lists. Again, we need to call this np.array to create a ND array out of a 2D list. And then we learned that we can use a comma notation only for the NumPy array, not for the 2D list. But for the 2D list, when we want to access, we have to provide 2 square brackets for both row and column. So these are the small differences that we learned. And then finally, we covered that what's the difference between the mathematical concepts of all this 1D array, 2D array, and all. And so this is all about the very basic array fundamentals. In the next video, we'll go more into details about the array attributes and various type of other methods and functions that are available to know about the array attributes. So see you all in the next video.